Hi, in the last session, we talked about concurrent statements in VHDL, and we also discussed process statement, component instantiation, assignment operator, when else statement, and with select statement. Now let's talk about generate statements in VHDL. So let's start. The generate statement in VHDL is one of the powerful tools which can be used for hardware instantiation. It comes with two main types. Number one is for generate statement and number two is if generate statement. Both these type of generate statements allows you to create multiple instances of hardware components, but they both have different purposes and we use them in different scenarios. We will talk about this in some time. But in short, for generated statement allows you to instantiate many number of components with very small section of code. And with if generated statement, you can instantiate your modules when it matches with some specific conditions. The if generated statement can be used to make your design flexible because you can trigger your hardware instances on or off very easily. So if you have the requirement when you need to create hardware when some specific condition meets, then you can use if generated statement there. Both type of generated statements can be used to create component instances, signal assignments, and even for the process blocks. Now let's talk about for generated statement in little more details. The for generated statement is especially useful for replicating the hardware. This means you can create many identical copies of the same hardware block with very minimum number of code. For example, if you need to instantiate 20 components in your VHDL file, then one simple way is to write 20 component instantiation codes manually. But this is not a good solution, and your code may look complex and it would be time consuming as well. So instead, you can use for generated statement, and that will allow you to instantiate all 20 components with just few lines of code. The syntax of this for generated statement is very similar like the for loop in the traditional programming languages like C or C++. In VSTL, you also mention label at the beginning of the generated statement. The loop parameter acts like a counter, which specifies the range of the values for each iteration, and the code within the generated statement will execute it for the each iteration. And this iteration creates the hardware instances or hardware blocks. Now let's see the syntax of for generated statement first. So we start from the label. It is any name. You should give this to identify the region for your generated statement, and this is useful for the future references. Then use colon and then write for. Then give the parameter name or range variable. Then type in. Now give the range of your loop. It will tell that how many instances it will create. Like if you give 0 to 3, then it will create 4 instances for each repetition. Next, write keyword generate. Next, you need to define the hardware which you need to generate multiple times. Then you can write your design here or you will call the components here. And in the last, this generate statement ends with the keyword and generate and semicolon. To understand this in little more details, let's consider an example where you have a 16-bit STD logic vector signal named as input signal, and you want to create two 8-bit STD logic vector signals named as even bit signal and odd bit signals. So the even bit signal will capture the even number elements from the input signal, and odd bit signal will capture the odd numbered elements from the input signal. First, let's see that how you will write them manually. So you need to assign each element in your code, and that would require multiple lines of code. For each instance, you need to write one assignment line. Okay. However, if you are using for generated statement, then it will simplifies your whole code. So let's see how to write it for the same example with for generated statement. Okay, so first of all, we will give it some label for generated statement. Then use colon and write keyword for. Then we will give some loop variable. which will define a loop parameter that runs from 0 to 7. So total 8 iteration in our example. Now within this loop, we will assign the even and odd elements of input signal to even bit signal and odd bit signal respectively. So we have written even bits count gets the value of input sig 2 multiplied by count semicolon. Next line is odd bits count gets the value of input signal 2 multiply count plus 1 semicolon. So you can see that how this approach reduces the amount of code to perform the same task. We have completed our task in just 4 lines. Instead, 16 lines in the traditional method, right? Let's look at the another example and it will make you clear how and where to use for generated statement. This time I want to instantiate a component of our entity sub1 20 times. If you remember, we created this entity sub1 in our previous video to show how component instantiation works. In that video, we instantiated two hardware blocks of entity sub1 and we instantiated them by manually writing the component for each instance. So we have written it 2 times. So now you can sense that for 20 elements of this component, you need to write your code 20 times for component instantiation. And writing these 20 component instantiation manually is going to take a lot of time. So let's see that how the generate statement can be used here. To start, I have written the skeleton for the for generate statement first. We used generate parameter I here, which is having a range from 0 to 19, which means this loop will run 20 times. Now look at the center body of this for generate statement. We write our code similar to the previous video. It is like that we are instantiating a single component block. So just like before, I have connected signal 1 to port A, signal 2 to port B, and sum to port D out. Well, if you run this code, then you will have 20 iterations. Means it will create 20 different components of entity sub1 and all the components will be connected to signal 1, signal 2 and sum respectively. However, all 20 components having the same inputs, so they are producing the same output. So here it does not sound very useful, right? It will be useful when each component is connected to the separate input and it will give the separate output, right? So to make this more practical, we need to modify the signal. Now we will make signal 1, signal 2 and sum into integer arrays with 20 elements each. This way, each component will have its own set of input and output signals. The code now will generate 20 components with each component having its own unique input and output signals connected to it. Now in this slide, we will see that how your code will generate 20 hardware blocks on the device. So for the first iteration, the for generate loop creates the first component instances of entity sub1. Now port sig A of this instance is connected to the element at index 0 of signal 1. Port signal B of this instance is connected to the element at index 0 of signal 2. And port D out of this instance is connected to the element at index 0 of signal sum. In the second iteration of the for generate loop, it will create the second instance of the component of entity sub1. Now the port sig A of this instance is connected to the element at index 1 of signal 1. Port sig B of this instance is connected to the element at index 1 of signal 2. And port D out of this instance is connected to the element at index 1 of signal sum. In a same way, this for generate loop will iterate 20 times and it will create the 20 components of entity sub1. Now each component has its own input and output signals, which are separated from the array index of the input and output signals. Okay, this means that each component can add two integers. And that allows us to use the circuit to add 20 different numbers at the same time and get 20 different sums as a result. Now, before we move on, let me quickly show you that how you can create the entire integer arrays used in this example. Although we already explained that in our previous sessions for user-defined data types and custom data types. Okay, so we need to define an array of 20 integers that range from 0 to 19. I have named this new data type as int input. Similarly, we define an array of 20 integers that range from 0 to 36. And this data type name is int output. Now we can use these two new data types to create a signal. First, we create signal 1 using int input data type. Then we create signal 2 and they both will use int input as in data type. Okay. Finally, we created this signal sum using the int output data type. Now let's talk about if generated statement. So the second type of generated statement is if generated statement. And this is used to instantiate hardware based on some specific condition. And this can make your design more flexible. Generally, this if generated statement is used to add any optional hardware structures in your design. The if generated statement allows you to trigger the hardware instances on or off easily. And this depends on the constant conditions, which is evaluated during the compilation. This means you can include or exclude certain hardware blocks based on your design parameters or configuration settings. You have to understand that this if generate statement is little different from traditional if then statement because you are only allowed to map any condition with a fixed constant. VHDL do not allows you to use any variable or anything which can change its value in the code itself. This means you can only use a fixed value of constant in this if generated statement to use any condition. This ensures that the condition is evaluated during the compilation and the appropriate hardware is instantiated accordingly. And the reason behind this is that the hardware is always fixed. Once hardware is fabricated, then you cannot add or remove any block from that chip, right? You can either use them or do not use them. But these blocks will be present always in the hardware IC chips because VHDL is a language for generating the hardware model. And hence, this is completely makes sense here. Hope you agree with me here. Now let's see the syntax of if generated statement first. So it starts with label colon if condition 1 generate. Now here it evaluates two primary conditions, condition 1 and condition 2. If condition 1 is true, then the VHDL compiler generates the hardware, which is specified in the first section of this block. But if condition 1 is false, but condition 2 is true, then the compiler will generate the hardware which is specified in the else if condition 2 generate section. And if both condition, I mean condition 1 and condition 2, both are false, then the hardware described in the else section will be generated. This structure provides a powerful tool to the VHDL designers to create the hardware designs, which can dynamically adapt to different scenarios or conditions. And this enhances the flexibility and efficiency in the FPGA and ASIC design methodologies. So you can sense that each section of this if generated statement allows for specific hardware configuration to be instantiated based on the conditional checks. And this optimizes the design reuse and the complexity management in digital circuit implementations. Now let's look over the simple example. Here we have a single condition named as assign to y. Here is how it works in practice. If assign to y is declared and set to true, then signal x will be assigned to signal y. This assignment is strictly determined during the synthesis phase and remains constant once the FPGA configuration is loaded. Alternatively, if assigned to y is false, then signal x will be assigned to signal z. So the condition assigned to y must be a constant and defined in your code somewhere. Means here you cannot use any signal whose value can change when the code drawn into the FPGA. So this condition assigned to y must either be true or false, and it must be defined as a constant number in your VHDL code. Now let's talk about little complex tasks. For example, we wanted to create an optional register in your design. So if a constant condition enable register is true, then I want to implement signal y at the output of the flip-flop, which registers signal x. Means signal y will be one cycle behind the signal x. Means if the enable register is true, then one flip-flop will be added to the signal x. Otherwise, if this condition is false, the signal will move straight from input to output without any flip-flop. Means simpler output wire will be connected to an input wire without any hardware in between. Okay. So this conditional instantiation helps in creating a flexible and configurable hardware designs. So in conclusion, the generated statements in VHDL are essential for efficient hardware design. The for generated statement allows for the replication of hardware blocks with minimal code, while the if generated statement enables conditional instantiation based on constant parameter. Both type of generated statement can be used to create component blocks, signal assignments, and process blocks, and that make them a versatile tool in the VHDL design. Okay, so we are reaching to the end of this video now. This was a quite long video, but this is one of the important feature of VHDL to understand. And with this, we have covered all generally used concurrent statements in VHDL. We talked about concurrent signal assignments, we talked about process blocks, then we talked about component instantiation, then we talked about when else statement and with select statements in VHDL. And in this session, we talked about if generated statement and for generated statement. Now in the next session, we will be starting sequential statements in VHDL. We will talk about process blocks. We will also talk about if-else statements, case statements, and many more things. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to our community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.